Hi class. In this lecture, we're going to start chapter 4 talking about exponential functions. And before we get to actually like what an exponential function is, and we're going to do graphing and modeling with exponential functions, what we actually want to do is start in section 4.1 and just talk about the properties of exponents. Basically, ultimately what this section is going to be about is how you simplify exponential expressions. Okay, so first off, what's an exponent? So for any counting number n, like 1, 2, 3, 4, -5, anything like that. Okay, b to the n power. We'll talk about the negatives later on, but for a counting number 1, 2, 3, 4, 5, b to the n is equal to b times b times b. It's just basically times itself n times. So we refer to b to the n as the power, the nth power of b, or b raised to the nth power. Okay, we call the b here the base and n the exponent. So base and raised to the n power just means times itself n times. Okay, so here's some properties we're going to be using. If m and n are counting numbers, then we have the following. If you have b to the m times b to the n, notice the bases are the same. What you do is this is equal to b to the m plus n. So this is the product property. So when you multiply two things that are common base, you add the exponents. If you have b to the m divided by b to the n, right? All you have to do here is you end up subtracting it. If the bases are the same, it's just b to the m minus n. Okay, this is as long as m is greater than n. We'll talk about the case where n is greater than m later on in this lecture. But that's the quotient property of exponents. If you have in parentheses b times c to the nth power, well, you can actually distribute the exponent to each term. So it's b to the n times c to the n. This is called raising a product to a power. And now talk about raising a quotient to a power. If you have b divided by c to the nth power, this is equivalent to b raised to the nth power and c raised to the nth power. So you can distribute the exponent to both the numerator and the denominator. Now, how about raising a power to a power? If you have b to the m and then that raised to the nth power, this is just equal to b to the m times n. So you would multiply the exponents here. All right, let's do a couple examples. Let's show that b squared times b cubed is equal to b to the fifth. Let's show that b to the m times b to the n is equal to b to the m plus n. And let's show that b to the n divided by, or excuse me, b divided by c to the nth power is equal to b to the n divided by c. Let's just work through those. All right, the first one here, by writing b squared and b cubed without exponents, we see that b squared times b cubed is equal to 2b's prime times 3b's, which is 5b's multiplied together. So 5b's multiplied together is indeed b to the fifth power. So that's how you get the 2 plus 3 gets you 5 when you're multiplying. Okay, you can verify this result is correct for various constant bases by examining graphing calculator tables for both of these. All right, if you were to put in your graphing calculator x squared times x cubed and then just x to the fifth, you would see that indeed for individual x values, they are equivalent. So these are equivalent statements here. All right, b to the m, b to the n without exponents. So b to the m is equal to b m times. B to the n is b n times. Well, that's just b to the m plus n. Okay, so when you're multiplying, you indeed do add the exponents. Here, same thing. Expand this out. This is b divided by c to the nth power is b divided by c n times. Well, we know that when you multiply fractions, you multiply across. So it's b times itself n times. And then in the denominator, it's the same thing, c times itself n times, which gets you b to the n divided by c to the n. All right, so how do we fully simplify an expression involving exponents? So an expression involving exponents is simplified if you have the following. All right, it includes no parentheses, okay? So whenever there's a parenthesis in it, you have to simplify until you don't get any. Each variable or constant appears as a base as few times as possible. So for example, if we have b squared times b to the fourth, to fully simplify that, it would be b to the sixth. So each numerical expression as something like 7 squared has been calculated and each numerical factor has been simplified. So you'd write like 7 squared is 49, right? And each exponent is positive, so no negative exponents. All right, so let's talk about how you simplify these right here. Okay, look at the first one. You have in parentheses 2 times b squared times c cubed to the 5th power. Well, the first thing you're going to do is you're going to take this 5 and you're going to distribute it to every term. So you're going to get 2 to the 5th power, b squared to the 5th power, and c cubed to the 5th power. Well, 2 to the 5th power is 32. And then remember, power to power you multiply. So 2 times 5 gets me b to the 10th power, and 3 times 5 gets me c to the 15th power. Same thing down here. All right, I want to simplify this. So I'm just multiplying everything. So what I'm going to do when I multiply it is I'm going to rearrange like terms together. So the constants, 3 times 2, b to the 3rd times b to the 6th, I'm going to write here. C to the 4th times c squared, I'm going to write here. Well, now let's just simplify it. 3 times 2 gets me 6. When you multiply, you add. So 3 plus 6 gets me b to the 9th, and 4 plus 2 gets me c to the 6th power. Okay, let's try these a little bit harder. So now here I have 2 division problems, okay? All right, so let's do this first one here, 3 first. So the first thing I notice when I'm going to color code the like terms here. First off, 3 divided by 12 simplifies to 4. And remember, when you're dividing, you subtract the exponent. So this becomes b to the 7 minus 2 and c to the 6 minus 5. Well, just simplifying here, this is just b to the 5th. And then c 6 minus 5 is 1. And whenever there's a 1 there, you don't have to put it there. So it's just c by itself. It's just b to the 5th times c divided by 4. Okay, now let's look at this crazy mess here. So when you have something like this, the first thing you're going to want to do is simplify the inside. So you're going to want to simplify what's inside the parentheses. All right, so I'm going to color code it here. All right, so first off, we can take the 24 and the 16. 8 goes into both of these, 3 times in the top, 2 times in the bottom. So 24 16ths reduces to 3 halves. B to the 7th, b squared, you subtract. So 7 minus 2 gets me 5. C to the 8 over c to the 5. Well, 8 minus 5 gets me 3. And there's no d up in the numerator here, so this d cubed just stays in the bottom. All right, so now this looks a whole lot nicer than this craziness here. So then what I have to do is I have to distribute this exponent of 4. All right, so again, I'm going to literally distribute it to every single term. Every single term gets the 4. Well, 3 to the 4th power is 81. B to the 5th to the 4th power, 5 times 4 gets me 20. C to the 3 times 4 gets me 12th power. 2 to the 4th power gets me 16. And d to the 3 times 4, well, that gets me 12. And this would be fully simplified. Notice no parentheses. Each base only occurs once. And this 81 over 16 doesn't simplify anymore. So whoop, we're all set with that. Okay, so let's just be careful here. So when you see the expressions 3b squared and 3 times b squared, they are not equivalent expressions. Like 3b squared is equal to 3 times b, whereas 3b squared gets you 3b times 3b, which is 9 times b times b. So just be careful of where you see the parentheses on this. All right, another thing, when b is not equal to 0, the base is not equal to 0. 0 to the 0 power, anything raised to the 0 power, even if it's like 10 million raised to the 0 power, it's always equal to 1. Okay, so let's now talk about negative exponents. If b is not equal to 0 and n is a counting number, then if we have b to the negative n, this is equivalent to 1 divided by b to the n. All right. So in other words, to find what b to the negative n is, take its reciprocal and switch the sign of the exponents. What I'll always say is bring it down. Okay, so if you have b to the negative n, it comes down into the denominator and you make the exponent positive. All right, the flip side also holds. So if you have 1 divided by b to the negative n, it comes up and it's equal to b to the nth power. So in other words, to find 1 divided by b to the negative n, take its reciprocal and switch the sign of the exponents. So to make it positive, bring it down. Or if it's already down, to make it positive, bring it up. That's like my trick to remember. All right, so let's simplify these expressions here, okay? All three of these. So 9b to the negative 7th power. Well, I can't have a negative exponent, so to make it positive, I bring it down. Okay, so I write it as 1 divided by b to the 7th. Well, 9 times 1 divided by b to the 7th is just 9 over b to the 7th. Here, I have a negative exponent in the denominator. So to make it positive, what I'm going to do is I'm literally just going to bring it up. Right? It comes up and becomes b, and then instead of the -3, it becomes to the 3rd power. Here, 3 to the -1 plus 4 to the -1. Well, let's make those positive. Okay, so bring them down. So this is 1/3 plus 1/4. All I did was bring these down. Then you need a common denominator here, which is 12. So 1/3 becomes 4/12. 1/4 becomes 3/12. So this is just equal to 7/12 right here. All right, all the same rules hold that we saw before. Even if there's positive or negative exponents, it doesn't matter. So if m and n are integers now, boom, all the same rules hold. If you're multiplying, you add the exponents. If you're dividing, you subtract the exponents. You can distribute the end to each term, both here, and still a power to a power multiply. All the same rules still hold. All right, so let's simplify some of these crazy ones here. All right, looking at this, 3bc5 quantity squared, 2b negative 2c to the 2 power quantity cubed. We want to simplify this. So the first thing you're going to have to do is you're going to have to get rid of the parentheses by distributing the squared and the cube. So you can see that done here. So just going through 3 squared gets you 9. B squared is b squared. C to the 5th squared gets me c to the 10th. 2 cubed gets me 8. Negative 2 times 3 gets me negative 6. And 2 times 3 gets me 6. Now you just need to clean these up. Now be careful with this negative exponent down here. I'm dividing, so I subtract. So the 9 and 8 stays. So this is b to the 2 minus 6. So double negatives are actually going to be positive here. And c to the 10 minus 6, well, this just simplifies to 9b to the 8th power, c to the 4th, all divided by 8. So notice how I got rid of the exponent on the outside first, all right, and then I simplified just using our rules. Let's try this crazy one. Okay, so I have this craziness in here with some negative exponents, and then I have a negative exponent on the outside. So first off, clean up the inside, okay? 18 divided by 6 gets me 3. This is b to the negative 4 minus negative 3, and c to the 7 minus 2. So when I simplify these simple subtractions here, I get 3b to the negative 1, c to the 5th. All right, now multiply or distribute this negative 4. So I get 3 to the negative 4, b to the negative 1 raised to the negative 4, and c to the 5 raised to the negative. Well, remember, a power to a power, you multiply. Okay, so this is still 3 to the negative 4th power. Negative 1 times negative 4 gets me positive 4, and 5 times negative 4 gets me negative 20. Well, now I have some negative exponents. Remember, to make the negative exponents positive, bring them down, and then you just have to figure out what 3 to the 4th is. Well, that's 3 times 3 times 3 times 3 gets me 81, just like that. Okay, now let's talk about what an exponential function is. So an exponential function is a function whose equation can be put in the form f of x is equal to a times b to the x, right? A is going to be a non-zero number, b is going to be greater than 0, and it also cannot equal 1. Excuse me, pardon me. All right, the constant b here is the base of this expression, or of this function. Excuse me again. A little bit of allergies, my apologies. Okay. So let's talk about evaluating exponential functions. So if I have f of x is equal to 3 times 2 to the x power, and g of x is equal to 5 to the x power, let's find the following. Well, f of 3, I'm just going to plug 3 in for x. I get 3 times 2 to the 3rd power. Well, 2 to the 3rd power is 8. 3 times 8 is 24. F to the negative 4. Well, I'm just going to plug the negative 4 in for the exponent here. Remember, to make it positive, you bring it down. Okay, so this -4 is only attached to the 2, so only the 2 comes down. So this is 3 divided by 2 to the 4th power, which is equal to 3 divided by 16. All right, g of a plus 3, just simply plugging in a plus 3 here and for x. Well, remember, you can split this up because when you had added the exponents, it was really multiplying. So I broke this up as 5 to the a, 5 cubed. Well, we know 5 cubed is equal to 125. So this is just 125 times 5 to the a power. You can do the same thing here. We have 5 to the 2 times a. Well, remember, multiplication implies it was a power to a power. So this is 5 to the 2nd power to the 8th power. Well, 5 squared gets you 25. And that a is still there. So it's just 25 to the 8th power. Okay, warning, it's common error to confuse exponential functions such as e to the x is equal to 2 to the x power with linear functions, all right, 2 times x. All right, so for the exponential function, the variable x is the exponent. That's important. And for a linear function, the variable x is the base. So just notice the subtle difference. It's exponential because it's raised to the x power, linear because it's multiple. All right. One last thing, let's talk about scientific notation. A number is written in scientific notation if it has the form n times 10 to the k power. Right? This is where k is an integer, and where k is an integer either somewhere between -10 and -1, or between 1 and 10. All right. So to write scientific notation, n times 10 to the k power in standard decimal notation, we move the decimal point of the number n as follows. If k is a positive, we multiply n by 10 k times. Hence, we move the decimal point k places to the right. Similarly, if k is negative, we divide by 10 k times. Hence, we move the decimal place to the left. All right, k places. All right, so let's write the number in standard decimal notation. So I have 3.462 times 10 to the 5th power. Since it's positive, I'm going to move the decimal place 1, 2, 3, 4, 5 places to the right. Okay. So we multiply this by 10 5 times. So notice how I'm moving it 1, 2, 3, 4, 5. If I move it past the last digit, I add zeros in. That's all I do. Now here, write this number in standard decimal notation. Notice how it's -4. So we're going to move the decimal to the left. 1, 2, 3, 4 places. So when you do that, watch. It was here. You go 1, 2, 3, 4. So I had to fill in 3 zeros here. All right, so to write a number in scientific notation, count the number of places k to the decimal point must be moved so that the new number meets this following conditions here. So if the decimal point is moved to the left, then the scientific notation is written as n times 10 to the k. If the decimal point is moved to the right, then the scientific notation is written as n times 10 to the negative k. All right, let's just do quick examples by this. All right, so I want to write this number, all right, 92,900,000, which is the average distance in miles between the Earth and Sun in scientific notation. And this right here, 0.0024, the average weight in grams. Okay, so for this number here, the decimal point must be moved 7 places because you start here, you go 1, 2, 3, 4, 5, 6, 7. So only there's one number left. So the new number n is between 1 and 10. Therefore, the scientific notation 9.29 times 10 to the 7th power, because I started here and I moved it that way. Here, look at this. I'm going to move it 1, 2, 3 to get the leading number there. So the decimal place must be moved 3 places to the right, right? So that the number is between 1 and 10. But because I moved it to the right here, this scientific notation is 2.4 times 10 to the negative 1, 2, 3. All right, class, thanks.